I can't call this E here because E is the identity element in G. Well, that might not be so instructive because we're looking at the identity. So let's look at phi of A, for instance. So that's lambda sub A. And where does this take E, A, B, and C? So now we're left multiplying each time by A. Lambda sub A left multiplies by A. So we're going to left multiply each of the elements by A and see what we get. So this is A squared is the identity, AB in fact is equal to C if you look at the table, and AC is equal to B. So phi of A in fact is what? Well, 1 has been sent to 2, and 2 has been sent to 1, and 3 has been sent to 4, and 4 has been sent to 3. Remember that E, A, B, C have been labelled with 1, 2, 3, 4. So A goes to this element of S4. Okay? And we're running out of time, but I'll let you check. So similar here is a bit cheeky in a way, but I'll let you check that phi of B is 1, 3, 2, 4, and phi of C, left translation by C, is 1, 4, 2, 3. Okay? So I'll leave you to check that. It's a similar computation to that. So what we end up with just to summarise, well, perhaps I'll revert to V for Klein now. So this was my G, the Klein group. So the Klein group is being embedded in S4. Just to summarise what we've done. I'm just writing down again what we've just found out. We've got those 4 elements of S4, so we've got the identity, and then we've got the 3 products of transpositions. And so phi square brackets of V is this subgroup. We could perhaps have called that iota or something. We've got these 4 elements of S4, and they form a subgroup of S4 isomorphic to the Klein group. So if we drew the group table of these 4 elements, you'd see you'd get something which was the same as the group table of the Klein group, apart from instead of E, A, B, and C, the elements are called these 4 things. So this is a group isomorphic to the Klein group that sits inside S4. So that was an example of Cayley's theorem, a group being embedded into a symmetric group, but also, going back to what we said right at the beginning of this lecture, we were thinking about the subgroups of S4. Well, we had the dihedral group D4 sitting inside here. Well, now we've got a group of order 4 that's isomorphic to the Klein group sitting inside S4. So we're starting to build up a little picture of what the subgroups of S4 look like, but in fact there's quite a long way to go. But there's certainly a copy of the Klein group inside S4. So the Klein group is lurking in various places in group theory, and it's actually sitting inside S4 as these 4 permutations.